In this tutorial, we'll learn how to use the Weighted Dictionary plugin for the Butter text analysis software. What this plugin will do is scan texts and score them for different categories that have been defined by a dictionary that is either built into the plugin or that you as the user have provided to the plugin. Now, a weighted dictionary approach is conceptually very similar to a traditional content coding approach, by which I mean these are different approaches that are built around what we call a dictionary, a list of words that have been identified as belonging to different categories of language or different categories of meaning, for example. Now, a traditional content coding approach essentially takes a text, counts the number of words that belong to each category, and then scores it as the number of words divided by the total word count. So, for example, if we want to measure the positive emotions in a text, we would have a positive emotion dictionary, count the number of words in the text that belong to that dictionary, and then we would divide it by the word count. The logic being that the more positive a text is, the more positive emotion words there should be within the text. Now, this is a very common and traditional approach that you'll find in psychology, sociology, communications, and even non-social sciences like computer science and some NLP and information science approaches. Now, a weighted dictionary approach is conceptually about the same, except that we know that some words are more positive than others, for example. Some words are more diagnostic of the thing we're trying to measure than others. And so, we may have a dictionary that weights the word wondrous as more positive than just the word good or nice, for example. And that's the weighted dictionary approach. So we're not just counting the words that belong to a category, but we're assigning them greater weights or lesser weights depending on how diagnostic they are of the thing that we're trying to measure in the text. Now, what we're going to do is we're going to go through how you would use this plugin first, and then I'll walk you through what an actual weighted dictionary looks like, what's contained within it, and how you can make your own in very kind of quick and easy terms. So we can see that this plugin takes tokens as its input type. So we'll want to make sure that we read in our texts and then tokenize them before giving them to the weighted dictionary plugin. For this example, we're just going to look at some TED Talks in the English language. These are transcripts I've collected over the years. Nothing too special, fairly straightforward. So let's go ahead and jump in, and then we can see what this looks like. So first we need to tell Butter where our texts are located. Then we need to tokenize them. Then we can attach our weighted dictionary plugin. Now if we go to the settings for this plugin, we can see that it has a bunch of dictionaries already built into it. And there's a little bit of information that we get with each dictionary. So we can see what the different dictionaries are. We can see if they have a prefix for the output. So this will become more clear once we actually analyze the texts. But many of these dictionaries have different categories that they measure. And so these prefixes help us see which categories belong to which dictionary. And then we also can see, as we click on different dictionaries, where they come from. So in a lot of cases we have citations for each of these dictionaries, so you can go and actually look up where the dictionary comes from and read the papers about them and try to understand better how they were designed and what they're intended to capture. And also just gives you a sense of what you can cite for each of these dictionaries that you might use in your research. Now you'll also see that you can choose which dictionaries you want to use, so you don't have to use every single dictionary built into the software. You can choose the ones that are most relevant to your research interests. So for example, you just want to measure concreteness in the text, you might want to use just a couple of the dictionaries designed to capture linguistic concreteness. Now additionally, you can also load your own dictionaries. We won't do that here because you haven't seen yet what a dictionary looks like, But just know once you've created your own dictionaries, you can load those up as well, and they'll appear here in this list. So for this example, let's just do the authenticity norms, and let's use the Lancaster sensory motor norms, and the World Wellbeing Project Gender Estimator. So we have three different weighted dictionaries that we're using here. We see that this one does not have a prefix, so that means it probably just gives us one category. This one does have a prefix, as does this one. Now let's go ahead and save our output, and we'll just name this file WD for weighted dictionary. And we'll go ahead and let this run for a few seconds here just so we can get some output, and then we'll go and see what that output actually looks like. So when we open up the file, we can see in the far left column, we have the actual text identifier, so we know which measures go to which text. We have the basic measure of token count, so we know how long each text was on average. And then from here on out, these are all weighted dictionary scores. So we'll start with authenticity here. Now this, you can see there's no prefix, unlike the Lancaster norms that all start with LENC underscore. This is the only category generated by that dictionary. And what we see is that we get a single score for each text for each of these measures. Now we won't go into the specifics of what each of these was designed to measure originally, but just know that what we're seeing here is the output of their scoring system that they developed. So in theory, let's say for this text here, it's 940 tokens long, so let's assume that 55 is the score that is the average of each of the words identified by that dictionary. So it looks for each of the words in the authenticity dictionary and then pulls in the weights for each word found and then averages them together. The same is true for each of these Lancaster norms here. And if we go all the way to the right, we have the Gender Estimator from the World Wellbeing Project. Now you can see that the scale of each of these measures is pretty wildly different. So the authenticity norms are clearly on a much greater scale. These are in the 50 to 60 range, whereas a lot of these norms here appear to be probably on a 1 to 5 scale, and the World Wellbeing Project scale actually runs into the negatives here. So this scale, the Gender Estimator, actually is designed to let us know in general what the presumed gender of the author is, and one direction versus the other, positive versus negative, corresponds to male versus female. This is also why it's important to go and read the original publications for each of these measures so that you understand what the scale is that they're using to measure, as well as what the actual metrics are intended to represent. Now that's the actual output from the plugin itself. Let's go ahead and look at some of these actual weighted dictionaries to see what's in them and how they work. So let's start out looking at the Warner Affective Norms list. And we can see this is just a plain text file that is essentially a tab delimited data set. So we can take this and copy it and paste it into spreadsheet software like Excel, which can make it a bit easier to view and sort and organize and think about. So within our weighted dictionary file, we can see that there are a few things going on here. So in the far left column, we see the actual words that are being captured by the dictionary. And then for each subsequent column, what we have is essentially how each word is weighted into each thing that a dictionary is designed to measure. Now there's a special row here The very first row of actual data is the intercept itself. For most purposes, this should be zeros. If you are working with very specific types of estimations, so for example, the World Wellbeing Project age or gender estimators, these are built using things like ridge regressions, or even just if you were using a linear regression. These will be the intercept terms of the models that have been created using these types of statistical techniques. For most cases, though, the intercept is just going to be 0. We don't want to score a text and then add or subtract any additional standardized value. Now if we go down and look at the actual words, for example, we can see the word abduct scores very low on valence, but very high arousal. And so as we're scanning through each text, what happens is we look for each of the words in this dictionary, and then we average these scores for each of the discovered words to get a single unified metric for valence, arousal, and dominance. Now let's look very quickly at the World Wellbeing Project Age Estimator. So here you can see there's just one column, so we're only getting an age score from this dictionary, and that there is indeed an actual intercept here. So once all of the scoring has happened based on the words discovered, this intercept, a constant value, is added to the overall average score. Now if you want to make your own, what you can do usually is start out in something like Excel, and you can use the general layout that you see here. So we'll start with a symbol and age column, and we start with the intercept. We'll set the intercept to 0, and let's say we were trying to create a dictionary measuring something like positive emotions. So from here we would add each of the words that we want to capture: happy, great, terrific, and then we would assign the weights to each of these words. So let's say happy is 2, great is a 5, and terrific is a 10. So once you've done this, you can simply take the dictionary that you've created, paste it into a text file, and save it from there. And then you can load up that text file and use it within Butter by loading it up into the plugin. And that's it. That's how we use the weighted dictionary plugin for Butter.